A lot of people underestimate just how deceptively complex catalytic converters are. They seem like these magical metal tubes under your car, but actually, there's an advanced science involved. People hear catalyst and think, I know chemistry, but the rabbit hole goes pretty deep. So, what actually goes on inside? You're looking at a honeycomb mesh, sometimes ceramic, sometimes metal, coated with precious metals like platinum, palladium, and rhodium. These aren't just expensive sounding, they're the heavy hitters that clean up your exhaust. 1 gram of rhodium is worth about $450 right now. Step 1, though, design. It's not just shove a tube under the car and call it a day. The mesh structure has to maximize surface area, and every little channel is crucial. If you fail here, the converter is useless, and you've wasted materials literally more valuable than gold. Next up, substrate production. Think firing thousands of tiny hexagonal tunnels from ceramic, all packed into a cylinder. These have to be ultra-thin, think 0.2 millimeters. Too thick and you choke off the exhaust, too thin and it crumbles before you even install it. Now you've got your ceramic honeycomb, but at this point, it's just an expensive piece of pottery. Next, you have to wash coat it. That means dipping the whole thing in a slurry of aluminum oxide, then baking it at temperatures that would melt a pizza oven. Here's a pain point: the precious metal coating. Balancing these metals is a dark art. Too little, and the converter does nothing. Too much, and your manufacturing costs skyrocket. And the price of these metals can swing by 30% in a month, so you're constantly number crunching. The actual application of metals is, weirdly, less high-tech than you'd expect. You basically dunk the substrate in a liquid solution, then bake again. The precious metals bond in a super thin layer, on the order of 1/10,000th of a millimeter. It's a process that can make or break your emissions game. After that, it's time for canning, shoving the monolith into a stainless steel shell. This involves crimping, welding, and making sure you don't introduce any leaks. A single pinhole and you'll trigger check engine lights across the city. Welding is an art in itself. You need a seal that can survive 1,000-degree exhaust temperatures and constant vibration. Miss here and you'll face warranty claims that kill your margins. Pro tip: always pressure test before sending anything out. Now, let's talk QC. You need to test every batch for back pressure and emissions reduction. Fail this and you risk getting blacklisted by automakers or facing EPA fines that bankrupt small shops. Numbers don't lie. 99.5% conversion efficiency is a must for modern vehicles. Here's the kicker: thefts of catalytic converters have shot up 325% nationwide. Why? Because those same platinum and rhodium layers are insanely valuable. The result? Security cages and serial numbers now have to be integrated during manufacturing. Another cost? Another headache. If you're ever in Portland and wonder why people chain their cars to lampposts, you'll see why. These converters have become the copper wire of auto parts, too valuable for their own good. I've seen $800 disappear in 15 minutes flat. Making a catalytic converter isn't for the faint of heart or short of cash. It's chemistry, metallurgy, and high-stakes market risk all fused together, right under your feet. When you hear one rattling under your car, know there's a whole world of science and expensive mistakes in that little can.